Hello, my name is Homa and now I'm going to introduce you to differentiation. So, differentiation is a fundamental concept in calculus, a branch of mathematics that deals with rates of change and the behavior of functions. It is a technique used to find the instantaneous rate of change of a function at a specific point and help us understand how a function's output, which is dependent variable, changes in response to changes in its input, which is the independent variable.
Hello everyone. In this slide, we're going to talk about application of differentiation. There is a lot of application, or we could say reward, by learning differentiation topic. The application can be seen in a lot of fields, especially architecture, medicine, and video game. First and foremost, let's see how the application of differentiation in architecture. Differentiation can be used to express design plan through graph or drawing. They can describe surface through map to help adapt the drawing to the computer software. For example, you can see the Eiffel Tower is designed by using differentiation. Next, application of differentiation can be seen in medicine. Differentiation is crucial for mathematical tool for analyzing drug activity quantitatively and utilize it to relate the concentration of drug in various body organ over time. Finally, we can see that application of differentiation can also be in video game. The graphic engineer use differentiation to determine the differences and changes in three-dimensional model. This helps to create a very realistic environment in 3D movie or video game.
Hello everyone. Now we want to solve the question. We start from question E. Y equal 5x power 3 negative 7x power 2 negative 7x plus 1. Question 1 asks to differentiate. So if we want to differentiate, we just do normally and we get 15x power 2 negative 14x and negative 7. Next we go to question 2. Question 2 asks about what is the stationary point. In order to find the stationary point, we must let dy dx equal to 0. Okay, dy dx we already get from this. We just put here and then equal to 0. And by using the formula of quadratic, we get two value of x and it is 1.294 and then the second x is negative 0.361. Okay, after we get the value of x, we want to find the value of y, and if you want to get the value of y, we must insert the x equal to 1.294 into the equation E, and then we get the answer of the value y is negative 8.945. And the same way we want to get the value of y, when we insert x equal negative 0.361 into the question or equation E, and then we get the value of y value 2.380. Finally, we get the stationary point is which coordinate x 1.294 and the coordinate y is negative 8.945, and we get also second stationary point, it is 0.361 as a coordinate x and then 2.380 as coordinate y. That's all from me. Thank you.
Hello. How many stationary point? In question 3, we get 2 stationary point. Next, the question 4. Determine x-intercept point and y-intercept point. First, x-intercept point. When x-intercept point with y equals 0, the question is 5x power 3 negative 7x power 2 negative 7x plus 1 equals 0. We get 3 bracket here with the factorization method. First, the answer x equal 2.039. Second, x equal 0.128. And third, x equal negative 0.767. The answer for intercept x is 2.039, 0.128, and lastly negative 0.767. Next, when y-intercept point with x equals 0, we get y equal 1. The final answer, the y-intercept point is 0, 1.
Hello, and now I'm gonna explain about the fifth step. So, for the final step, we are going to determine the minimum point and maximum point. So here, differentiate again, and here we got 30x and negative 14. To determine the minimum point and maximum point, we just have to use the value of x that we got from the earlier steps. So for the first x, when x is equal to 1.294, we will get 24.82, which is bigger than 0. So because it is bigger than 0, it is minimum point. So for the second x is equal to negative 0.361, and then we will get negative 24.83, which is lesser than 0. So because it is less than 0, it is a maximum point. So for the final answer, we got the coordinates, which is point 1.294 and negative 8.945 is minimum point, and point negative 0.361 and 2.380 is the maximum point. So this is the graph that we get from question E. So first of all, we got 3 x-intercept and 1 y-intercept. So for the first x-intercept, the coordinates are negative 0.767 for coordinate x and 0 for coordinate y. For the second x-intercept, we got 0.128 for x coordinate and 0 for y coordinate. And for the final x-intercept, we got 2.039 for x coordinate and 0 for y coordinate. And for the y-intercept, the coordinates are 0 for x coordinate and 1 for y coordinates. And then we got the minimum point here and the maximum point here. So for the maximum point, the coordinates are negative 0.361 for coordinate x and 2.38 for coordinate y. And for the minimum point, the coordinates are 1.294 for coordinate x and negative 8.945 for coordinate y. That's all. Thank you. So now we are going to do the question F. So for question F, y is equal negative 5x cubed plus 7x squared plus 7x minus 1. So for the first step, we are going to differentiate the equation. So it will become negative 15x squared plus 14x plus 7. So for step 2, at stationary point, dy per dx is equal to 0. So here we got negative 15x squared plus 14x plus 7 equal to 0. So here we can solve it by using the quadratic equation, and finally we will get x value, which is the first one is negative 0.361 and 1.294. So after we got the values of x, we just have to replace the x with the values that we got. So we just use the original equation. So when x is equal to negative 0.361, it will become like this. And also the same when x is equal to 1.294, it will become like this. And finally, we will get the stationary point is negative 0.361 and negative 2.380 and 1.294 and 8.945.
Below the third question, we got 2 stationary points. Next, the question 4, determine x-intercept and y-intercept point. First, when x-intercept point with y equals 0, when y equals 0, the equation is y equal negative 5x power 3 plus 7x power 2 plus 7x minus 1. Negative 5x power 3 plus 7x power 2 plus 7x negative 1 equals 0. We got 3 bracket here. We use the factorization method. The first answer we got x equal 2.039. Second, x equal 0.128. And lastly, x equal negative 0.767. The answer x-intercept point 2.039 for x and y, we get 0. The second 0.128 for the x and we get the 0 to y. The third negative 0.767 for the x and the y, we get the 0. Next, when y-intercept point with x equals 0, we get y equal negative 1. The final answer for the y-intercept point, we get 0, negative 1. Thank you.
On this slide, I'm going to discuss the solution for question V. Question V asking to find or determine which stationary point is maximum point and minimum point. In order to determine it, we differentiate again, or we call differentiation second order. We get negative 30x plus 14. In order to determine the stationary point is maximum or minimum point, we put x equal negative 0.361 into the differentiation second order. We get 24.83, and we know that 24.83 is bigger than 0. If bigger than 0, it's minimum point. Next, we want to determine its stationary point is maximum or minimum point. We put x equal 1.294 into the differentiation second order. We get negative 24.82. Negative 24.82 is less than 0. So we know that when it less than 0, it is maximum point. The stationary point is maximum point. And here the answer: point coordinate x negative 0.361 and coordinate y negative 0.380 is minimum point. And the second point, the coordinates 1.294 and coordinate y 8.945 is maximum point. Okay, here the graph from question F. As we know, the question F, we get 2 stationary points, 3 x-intercept and 1 y-intercept. First, we see which is minimum stationary point, which is minimum point is from this negative 0.361 for coordinate x and negative 2.3x for coordinate y. And for stationary point, which is maximum point, is 1.294 for coordinate x and 8.945 for coordinate y. And after that, we want to determine which is x-intercept. X-intercept is negative 0.767 for coordinate x and 0 for coordinate y. And then second x-intercept is 0.128 for coordinate x, and for coordinate y we get 0. And for the x-intercept is we get 1.039 for coordinate x, and for coordinate y is 0. And lastly, we get only one y-intercept, and it is 0 for coordinate x and negative 1 for coordinate y. That's all from me. Thank you.
In summary, differentiation in the mathematical to the reveals the secret of transformation and evaluation. From its historical root the Newton to its modern day application, we have unraveled the ancestor of change itself. We are divided into the fundamental concepts, including derivative and their calculation, and ventured into the diverse domain where differentiation play a central role from physics to economy. As we include, remember that differentiation is the key to unlocking the dynamic intricacies of our world, offering a clear perspective on how things evolve and adapt. Thank you.